Can we talk to them? We can't talk to them. Oh dear. Welcome, guys. Today it's all about sliding head lathes. Last week we were talking all about work holding, and how did you guys think it went last week? Work holding.
Yeah, I thought it was good. It's pretty informative. I learnt quite a lot from Gio.
I learned a lot from Paul. And,
did you?
Yeah.
Oh, wow.
We've seen some of the reviews after as well. That you shared some of the snippets.
Yes.
On LinkedIn, and people were chipping in and adding different versions of how they would do it. And that is the thing. There's so many different ways to skin a cat. There's not necessarily one right way. There's lots of different ways dependent on what machines you've got.
And then I'm glad I'm wearing a pair of trousers this week. So
Yes.
a few people commented on that. But this time tomorrow, I will be in a pair of shorts because I will be overseas.
Not just to mention, you are wearing a pair of shoes as well.
Pair of shoes as well.
You didn't wear any shoes either. Oh, it was awful, wasn't it?
And my Nicola, my partner, we got back home and she watched the question time. She says, "Why is Paul in shorts?" And I said, "I'm not sure." She says, what's wrong with that? And she's like, "It's winter." She's one that always likes to wrap up at the freezing cold.
It is absolutely freezing. So, while we're live, guys, and Gio just mentioned, it's absolutely, imperative to get you guys' opinions and comments and questions on sliding heads, which is obviously the topic of discussion today. I thought I'd just get together a little bit of a fact prior to obviously, going through some of the questions that you guys have been asking us throughout the week on sliding heads. So an important early lathe that in the UK was a horizontal machine that was installed in 1772. It was horse powered, and one of the key characteristics of this machine is that the workpiece was turning as opposed to the tool. So it was technically making it a lathe. Now I've got quite a few actual facts on sliding head lathes at the moment. Have a guess, guys. What is the earliest form of a sliding head lathe? Gio, you already do have a bit of a
what was the date?
You've had a clue on this earlier.
What was the date that you said there? 1772.
This is 1772. Guys, if you guys would know,
1826.
1826, one of the earliest metal lathes that was the first of its kind ever made was actually in the 3rd century BC.
Oh, sorry, of any lathe. Oh, right, okay, yeah.
Yeah, no.
Nevertheless, I still think that is an outstanding fact, really.
Yeah.
That from all that time ago.
Yeah, but just think they had, the wood, everything's always got to be made.
Oh, of course.
Whether it be today, 10 centuries.
Was it the Egyptians?
It was ancient Egyptians, and what they did is it was the mother of machine tools, because they started to make actual machine tools from that machine, and it's absolutely incredible.
Yamazaki Mazak still referred to their machine tools as mother machines.
Yeah,
for that fact.
That's exactly it. Mother of machines. So we're talking about mother of machines today. So sliding head lathes is the topic of discussion on MTD CNC's Question Time. So if you have any questions, I'm going to keep saying this. Please feel free to just comment your questions, and they will come to me through here. So we are live, and obviously just ask your questions to Paul, Gio, and we'll get them out. So we've got our first question of the day here, and it's: I watched your video from Star GB. Fantastic, thank you. How would you recommend to make prismatic parts? So who'd like to go first on that one? So that's a...
Well, you go first,
we did review that at Star, to be fair. But I suppose it was more about the machine and the actual way in which you would look to make prismatic parts. But I think the point that me and Paul were trying to get across was the versatility of a sliding head machine. So in the past, historically, you would look at a sliding head machine to make cylindrical parts, round parts, in high volume. That would be an automatic thought process of what if you were in the market for a sliding head. However, we've now increased bar capacity with lots of milling options, B-axis, live tooling on bottom turrets, etc. There's no reason why you can't make prismatic parts from the bar, but not only in very high volume work, but also in medium batch volume. Like a perfect example that we used, for example, the aerospace industry, where you've got a family of parts that are very similar with just a few different variants or variations on a theme.
Yeah, I think they have changed and evolved so much, the machines, that a lot of it has come down to the fact that they've wanted to get manufacturers have wanted to make their machines get into new markets. And how do you do that? Well, you look at the things that the machine can't do and you try and adapt them to do the things they can't do. And the biggest restriction and the biggest barrier on sliding head turning was the fact that you could do all the turning, but you could be restricted in the speed of milling, in the materials that you could mill. But all of those sort of aspects have been addressed now. And you can actually do, whether it be just simple flats to off-centered, to keyways, to all of those elements you can do. And that obviously then brings you into the fact that you can now begin to do prismatic parts that you would previously have thought would have been done on a machining centre. I'm not sure quite what the video was that was being watched, because we did quite a few there. But I know there was one application where it was a very, almost like a part from a connector part or something. And you looked at it and you thought to yourself, well, okay, it's small. Yeah, granted it was small, but it would have, in history, probably have looked to have been made in volumes on a machining centre. Well, that would be the first sort of machine you would look at. But now it's that change of mindset. It's the fact that it doesn't matter, how much stock needs to be removed, because the machines have the power to do that. It doesn't matter about the complexity of the component, because the machines have the axes to accommodate those. So really, if you've got prismatic parts and you're under pressure by your customer, because a lot of these things are driven by customer pressure, aren't they? The customer wants cost down. You want to get the part off the machine as quick as possible. With a machining centre, you will generally have to have an operator there to load it, take parts off. With a sliding head lathe, making something out of bar, you can run it through the night. So you're taking a lot of those costs out of the manufacturing process, giving your customer cost down, or your costing down, so you can make those prismatic parts. And they've made their machines capable of that.
And that's the thing, really, prismatic parts through the night. So you'll associate, again, sliding heads with round parts through the night. You part them off, this, that, the other. Prismatic parts through the night being bar fed. This is something that's still in its infancy. It's still relatively new. I don't know how many people have embraced this yet and started to work like this yet, but we went to a company, I can recall, Paul, I can't remember the name of the company, where they were making components for tripods, actually. Can you remember? Yeah. Where they'd actually introduced, they were doing the parts exactly in that way, and I can't remember, but they'd reduced the cycle times.
Well, what had happened, and this is something that is so important to put across, is they'd been given a drawing for an additional component, and the machines that they had could make that part, but they looked at it and they thought, well, they want them for X amount of pence. I can't begin to make them for that sort of money. But what they did do is they'd actually seen some MTD videos about milling and doing square parts. They contacted Star and said, look, we can win this order if we can make this part for 15 pence, 20 pence, but there's no way we can do it on a machining centre. Any way we can do it on a sliding head lathe. And of course, as a result of the speed, the axis capability and all that, they actually could do that on the machine. You can
find that video on MTD CNC. We'll after the show, we'll maybe put a link onto LinkedIn, so you can maybe put that on there, Gio, so people can watch that video. Yeah, that's a real life application.
Changing the mindset, getting a part. Often engineers will get drawings through and they go, I've got to make it for that. Someone's making it, no chance. Well, maybe you can, because if someone else can, it's probably down to the hardware that you're using and the machine that you're using and the strategy.
Definitely, that's amazing. Thank you, guys. That was a big question. And if you guys would like to obviously jump on board, comment, and maybe you've got some recommendations that you can make. And obviously that's why we're doing MTD CNC's question time. It's kind of like building that community and obviously feeding back advice. So if you've got any questions in regards to anything that we're saying, and if you've got any questions about sliding heads today, feel free to just jump on. I've got Sarah Parker on Instagram, so hello there, Sarah. I've got another question here, and that's, what's the difference between a sliding head machine and a fixed head machine? So who would like to answer that one?
You again. You're always best.
A fixed head lathe, so your spindle that rotates, or you put your work holding onto the spindle on a fixed head lathe and it rotates, and where it clamps the component, that is the position. It's fixed. It doesn't move backwards and forwards. It's in a fixed position. Behind the spindle, you've got a cylinder and a jaw tube that actuates the jaws, but effectively then you're spinning the part, and it just opens and closes with the cylinder at the back. With a sliding head machine, what you've got is you've got guide bushes that are at the front, then you've got an headstock at the back, you've got a collet chuck as well, and then it's driven as well. So and on that headstock, it's on guides. So they slide, and you've got a stroke. So the headstock slides. The difference being with the fixed head and the sliding heads, on a fixed head, the component is turning, and the tool will be going through the component, moving through the component, backwards and forwards. On a sliding head machine, with the stroke of the headstock, the material is moving to the cutting tool. So you are always right. You're always cutting right near to the holding point. So wherever that holding point is. So when you're doing thin, long parts on a sliding head, that's how you get that concentricity without any taper. And you can turn them really long parts, so accurately. So I don't know if that's clear, but that's the difference. So sliding head, the headstock moves and you've got stroke. Fixed head, the spindle stays in a fixed position and the tools move.
Excellent.
Perfect.
Yeah.
Perfect.
Could you add to that at all, Paul? Or is yeah, it's all good.
I don't need to.
Did that make sense?
Perfect.
I don't know if that.
Well, let us know if that made sense to you out there.
Yeah.
I've got to say hello to I do apologise. I can't pronounce that. Can you see that, Paul? What does that one say?
TCA Dari Khan.
Hi there. Thank you for joining us. And obviously, if you've got anything to add, I might sound like a broken record as we keep going, but I really do want to encourage you to ask any questions while we are live, and you've got the opportunity to ask absolutely anything in regards to sliding heads. We've got Paul here, we've got Gio here, we've got the experts here, so make sure that you are obviously asking anything. It doesn't matter even if it sounds silly, just ask away. We're going to be here for a little while. So I've got another question here, and what are the milling capabilities with a sliding head lathe? So who would like to answer that one?
I mean, they're far greater than they used to be. They're far greater than they used to be. Maybe 5-6 kilowatts on some machines on sliding head. In fact, even more than that. In fact, one machine I think had sort of 15 or 20 kilowatts on milling, which was, that's pretty heavy duty milling. This is an area, going back to the first question, that manufacturers have spent a lot of time developing their machines in order to be able to improve the milling capabilities, because they knew that was a weakness of those machines. You make the machines heavier, they might be 5 tons, some of these sliding head lathes now, so the weight's in the casting, it dampens out any of the vibration, take bigger cuts, less tool wear, all of those things. So the milling capabilities of the machines now are far greater than they were a few years ago, and it doesn't matter what material you're cutting, and the depths are significant.
Brilliant.
Can't really add too much to that myself.
No,
really. I mean,
right.
you've got the bottom turret, haven't you, Paul?
Yeah, you've got bottom turret.
With live tooling, got a big chunky turret.
Yeah,
and you've also got the B-axis with spindles on that you can do milling on.
And I mean,
too,
when you look at a turret on a sliding head lathe, you do some of the turrets you look at and you go, that is for serious machining. This is no longer for tickling components. This is for ripping material. So the milling aspect is a big part, and I'm sure will come up again in this topic of conversation. But don't be scared to test out with suppliers what they can do for milling.
In my opinion, I think the fact that has been introduced, that technology now is available, and you can cut them hard materials now on a sliding head. It's a game changer.
Yeah,
it really has changed the game.
Yeah,
brilliant.
100%.
Awesome stuff. Okay, so hello to BTM Machines on Instagram. Instagram seems to be very popular at the moment, so thank you guys for obviously joining into the chat. Again, if you would like to ask us anything, please feel free. It's Sliding Heads today on the MTD CNC's Question Time, so thank you for obviously joining us. We're also live on Facebook, YouTube, Instagram, Twitter. So if you wanted to obviously go on any other different platform, feel free to obviously join them. But we are going to be going live regularly on a Friday for MTD's Question Time. So the topic of today is sliding heads. So feel free to jump on and ask away, or even just comment or have, share your opinions or experiences with sliding heads and what we're discussing today. So I've got another question here, and it's, what's the B-axis do on a sliding head machine? So
that's for your for your angled features on components. It's essentially, it's probably 110 degree motion on the tools with drilling capability. So if you've got a turn part and you need to put an angled hole in it, or something that's unregular in terms of turning and milling, if it's on an angle, if it's a slot, if it's in a groove, you can basically angle your B-axis in order to machine at different angles on the machine. And they're quite powerful as well. I know I keep coming back to it, but some of these B-axis really enable you to take a part that's complicated, and instead of moving it from machine to machine, you can make it all on one machine. And you can't talk about how influential that can be in making production far easier and making parts far quicker if you can do more complex parts, and that's what a B-axis does.
And in my opinion, again, I think they have evolved significantly over the years. I think that in the past, potentially a B-axis was positional and manually positioned. So say, for example, you had a component come in where you've got a two-way compound hole, you position that B-axis just to do that batch of work, but then when you come to do another part that doesn't require it or requires it at a different angle, then you'd manually position it again for that next batch of parts. Now I believe they're programmable as well.
And if you buy a sliding
the front
head
and
lathe,
back.
I know there's additional costs to these, but you imagine you had a part and you were doing all the turning and milling, and you had to take that part off because you had to stick it on a fixture on a machining centre to drill a hole or something.
Yeah.
Those things happen. Those parts are out there in all kinds of industries.
It would be another machine, another process,
machine, another setup,
operation,
another person, another risk of error.
Yeah,
you could turn. It's all of those things. A B-axis will address all of that, and as Gio said, even for simultaneous operations as well now.
Yeah, servicing back and main and second spindle.
Yeah.
Blimey. Wow, thank you. And if you guys obviously would like to add to that at all, or if you've got experience in B-axis machining with a sliding head lathe, then feel free to share your opinions and comments. We've got to say we are current. Oh, say hi to Squad CNC on Insta. So hello, Squad. Well, I'm named. So hello, Squad CNC on Insta. And Tom, the UK machinist, I think that is our friend Tom, Scooballs, on Instagram. So our next question is, are sliding head machines powerful enough to machine hard materials?
100%,
yeah, definitely.
So short answer is yes.
Yes,
definitely.
No concerns
there's no limitations. I mean, when you're cutting hard materials, you'll adjust your strategy and you probably use different tooling in accordance to get the best results. But in terms of the stability of the machine and the structures of the machine, machining techniques have changed. Like, we were at ISCAR this week looking at machining harder materials. And a lot of it is to do with the machine, but a lot of it is to do with the tooling that you use in the strategy that you adopt, the feeds, the speeds. Some of the things we saw this week at ISCAR, you'd think, they were cutting Inconel at like 10,000 RPM, weren't they? One of the demonstrations, and a lot of ceramic tooling being used for certain applications, and all of these things are adaptable across all platforms of machines. And I think that the machines are more than capable of machining hard materials efficiently and accurately over a long period of time.
I'll give you a good example as well, Gina. We were at the Star Open House again. Sorry to keep referring to the Star Open House, but it was just recently that we visited for that event, and they brought a new model out. I think it's the SX, isn't it, Paul? From recollection, it's got 11 kilowatts power on the main spindle, 11 kilowatts power on the second spindle, and the machine weighs 5 ton. So when you've got that kind of rigidity, that power, you haven't got any issues in regards to cutting them exotic hard materials. Put that with the strategies and cutting tools.
What is also interesting as well, you talk about the hardware. Software has a lot to do with this now. Like in some of the suppliers' controls, they can monitor cutting cutting feed rates, and they can monitor stresses on the tools. They can monitor stresses in the spindles. They can monitor all of those elements in order to, react and change how the machine is cutting to get the best on different materials.
And mentioning software as well, chip breaking technology.
Chip breaking
all of the leading sliding head providers now have got their own version of this, which helps again.
Yeah, definitely. Yeah.
Brilliant stuff. Thank you, guys. If you guys have any questions, feel free to jump on and ask these guys your questions. If you use the hashtag MTDQT on Twitter, we'll be able to see your question pop up immediately. Hello, Mike Green on Instagram. Again, Instagram seems to be obviously lots of people are joining that, so that's great. Please feel free to obviously ask any questions or share your experiences on sliding heads. I've got another question here, and that's, what's the difference between guide bush and non-guide bush? And I'm sure that Gio will be able to answer that
this
one.
is such a common question, isn't it? So when you're using a guide bush, that is predominantly when you're doing longer work on a sliding head lathe. So you can kind of, basically the bar can be fed out of the guide bush. When you're doing non-guide bush, effectively you can utilise the machine bore, so you can increase the bar capacity from 32 to 42.
42 sometimes, or even 45. I think.
But I'm not sure of the capacities, but effectively taking that guide bush out enables you then to hold larger bar diameter. However, the restrictions to that is the length of bar that you can hold. So effectively, you are holding the bar in the back collet, but they recommend that you only hold maximum length of 3.5 times D. And that bar would not be moving back and forwards through the collet. It would be moving just on the headstock slideway. So if, for example, you were just doing washers, that were only 5mm thick or something like that with a few milling features on, and you didn't need to do long bar, but they were at the maximum diameter of 42 non-guide bush, and you'd also have another advantage of that you'd have shorter remnant waste as well. But if you were doing long parts that required that guide bush for supports, like we mentioned, so you're cutting right next to the guide bush at all times, guide bush. So again, flexibility.
And you can change quite quickly on all of most manufacturers' machines now will have the option, and some say that you can change within 15 minutes from one to the other, which it really assists in when you're wanting to do those different styles of work, quoting different jobs, factoring in the times within the machine shop. Those things are important as well. If it took a day to change from one to the other, it would become costly.
And I think that's why there is becoming a bit of a crossover as well between fixed heads and sliding heads, because albeit you've still got the slideway that's moving, you are actually keeping the bar in a fixed position in that collet chuck. So that's kind of it's not a great analogy, I suppose, but that's the how you can kind of look at it, and you're holding bigger bar.
Yeah.
Brilliant. Thank you, guys. If you guys have just joined us now into our chats, then please feel free to obviously ask these guys any questions. We've been clearing up so much in regards to sliding heads on MTD QT, so you can hashtag that on Twitter, and we'll be able to see your questions immediately. So I've got another question here. There's lots of news on chip breaking technology. What do you guys think about this? So who would like to answer that
important, really important, a really great invention or a really great change or addition to sliding head turning, because we go in so many machine shops and see engineers that have found this is just groundbreaking for them. They can leave, the chip breaking element means that whereas you might have got stringy swarf before, then you need an operator there to make sure you can keep taking the swarf out of the machine. You can clear the working area. You don't need that anymore when you've got chip breaking software. There is arguments to say you have to slow the machine down slightly, but slowing the machine down by a few percent in order to leave the machine running overnight without an operator is massive, is absolutely massive. And most of the machines I think that the suppliers sell now certainly have the option to retrofit it, if not supplying it with it. It comes into its own with those more sort of difficult materials, but it's a massive benefit.
It's a no-brainer, and I think that now that people, like you say, it's created a stable process it's enabling customers that were unable to run 24/7 to run 24/7 confidently. And also, if you were turning parts that didn't require chip breaker technology, you wouldn't need to slow it down. It's only when you're cutting, like you said, them stringy kind of funny materials, so you could effectively turn it on and off whenever you want. So when you come back to the day shift again, you can turn it off and run it fast. So, but to get that unmanned running, that is, I think, the key.
I always think with these things, when you look at where a sliding head lathe fitted before you had maybe more power, before you had B-axis operation, before you had chip breaking software, your market of opportunity was, X amount of hundreds of companies a year. Now I see, that was your opportunity before. Now you've got the addition of these features on the machines. Your opportunity is so big with sliding head lathes because they are just so versatile. Now.
And to anybody out there who isn't familiar with like chip breaking technology, can you just give us a little bit of an overview? What does that?
How it works?
Yeah, how does it work?
I mean, it is basically whereas if you had a continuous cutting motion, the swarf would always be continually being cut, or the cutting edge would be on the material all the time. So as you're cutting, you are creating. We've all seen it. The swarf is not chipping; it's just stringing off. Whereas if you imagine exaggerated, you sort of either stop started, or came in out like that, or however the motion is. That is essentially what it is doing. Yeah. Now, some might say, is there an impact on the surface finish? Well, again, I mean, that's only for the sliding head lathe suppliers to comment on. Is there an impact on speed? Yeah, I'm told that it is a little bit of a slower process, but as Gio correctly said, the perfect word to explain it is a stable process. But that is how it works.
But it can even say, 100%. I think it can save times on certain components. I mean, if you've got that stable process, you're not going to scrap a part. You can just walk away and feel confident that it's going to do the job.
Yeah. Yeah.
Brilliant stuff. If you guys have just joined us, we are talking everything about sliding heads today. We've got a series of questions that we've been going through. Feel free to obviously jump on boards and obviously ask as many questions as you like in regards to sliding heads. I think we've just had someone comment, are we giving away a swarf bag to a lucky viewer next week? Are we? Is that a yes? Should we say yeah? Yeah?
Yeah.
There we are. We are giving away a swarf and chips goodie bag for a lucky viewer. So obviously, maybe the best question, something like that. The best question regarding sliding head. Yeah. We will give you a swarf and chips goodie bag. So make sure you are getting your questions in. We have got a hashtag, and that's MTDQT. So if you are on Twitter watching us and you'd like to ask your question, feel free to do that using the hashtag. We've got another question here, and it is, how is the software improving the sliding head technology? Have we just covered that in regards to the chip breaking technology, or is there any more?
To a certain extent, that is one area. There's a few areas of software. There's the creation of the program, almost like the CAD element, the design, the importing of the drawings. How you create a program easily is critical, because you want to be able to take a complicated part and program it easily. So that software is improving in that way. The software is also improving in the fact that you can monitor machining operations. So you're monitoring machining operations and seeing feedback and getting data back to yourself as to whether you can push it a bit faster or you need to back it off. You can then analyse tool wear versus cost on what you're creating. There's all of those features that are and the chip breaking that we said. All of those elements are having a big impact. As one thing Gio always says is the hardware's come on so far. A lot of the improvements are coming in software now, and that is very true for this. Although I still believe that there's been a lot of developments in hardware in sliding head turning in recent years.
Definitely, I couldn't agree more. It's perfect.
Brilliant, excellent. And guys, this will be we've got our last question here. If you guys want to jump on board and obviously ask any more questions, feel free to do that via the chat that you're looking at. But yeah, we will go over the last question that we've got, and it's, I've seen a couple of videos of you guys at Star GB, awesome, where there was a FANUC robot automating it. I know you did explain it in the video, but can you tell me a little bit more about that?
Okay, yeah, that was the video. The video that was online. In fact, there's a few videos online. The thing I learnt about this is taking the part off of the machine, and it's then. It's not necessarily measuring that. Well, it is measuring that part, but it's got a component that it started with, and it's taken those dimensions, and they become what you call center ground. And then when a part then comes out of the machine, it's picked up by the robot. It's cleaned, it's orientated, and then it's put into a equator system, and then it's compared. It's compared to the one that's right,
Yeah.
and if it fits within limits below or above, it then gets taken off of the equator and put into the pass bin. If it's outside of those limits, it then gets put into the fail bin. Now, the point in showcasing this was the fact that that the partnership shows that sometimes with sliding head lathes, doing measurement on the machine can slow the process really as well, because you want to be turning components. Do you want to be using in machine measurement at those for those critical operations, or can you do it outside of that working area? And it's just showing that the collaboration between robotics, metrology, and sliding head turning. So that's how it worked. And there was more in the pass bin than the fail.
That's good. No, honestly, it was an incredible machine to see. What was it? A Star? What was the actual model of the machine?
I think it was an SR32.
Yes, it was.
Type.
Yeah, Type A. I believe, with a FANUC robot and a Renishaw
equator. Yeah.
Yeah, it was amazing. Absolutely awesome. So we've got no more questions that have come in. So obviously, thank you guys for tuning in and watching us. Obviously, we are going to be here every single Friday on MTD CNC Question Time. We hope that you've enjoyed it, and we've covered all angles on sliding heads today. We're going to be announcing what next week's topic of discussion will be very, very shortly. So have an incredible weekend. Are you guys up to anything good at the weekend? Or
going on holiday.
You're going on holiday? You are going on holiday. He's always on holiday.
Cannot wait.
Oh, amazing. No, and Gio, you up to anything?
A meal tomorrow night, that's about it really.
Yeah.
It's a bit of a quiet one.
Are you not having one tonight as well, or are you going to wait until tomorrow?
No, I'll wait till tomorrow. I'm on a diet.
All right, thank you guys for tuning in, and we'll see you next week.
Thank you.